When adding mixed numbers, we use a similar process that we did when we were adding regular fractions, whether they had common or uncommon denominators. So we're going to do some examples of each. Starting with just regular fractions that have uncommon denominators, we used the strategy before of stacking the fractions to help us organize creating those common denominators. Between 3 and 4, a common denominator is going to be 12 because 3 times 4 gives us 12. So we write that farther to the right. 4 multiplied by 3 gives us 12. So we would have to multiply the numerator also by 3 because that needs to match within the same fraction, giving us 3/12. In 1/3, we would multiply 3 by 4 to get 12. So we also have to multiply the 1 by 4. And then we have 3/12 plus 4/12 now with common denominators. 3 plus 4 gives us 7, and the denominator stays the same. Then you always check to see if you can simplify, which in this case we can, so that would be our answer. When we were adding mixed numbers, we stacked them the exact same way. The first one listed on top, with the second mixed number underneath it, lining up those whole numbers. So 2 and 1 are our whole numbers, we want them in line. 2 and 3/5 plus 1 and 3/5. You'll notice that we already have common denominators, so we don't need to multiply to create a common denominator. We can just add the fractional parts. Always add the fractional parts first. And then we'll add the whole numbers. In this case, 3/5 plus 3/5 gives us 6/5. 2 plus 1 gives us 3. So we've added the fractional parts and we've added the whole numbers. You'll notice that within this fraction, the fractional part is an improper fraction. It's top heavy, so we have to fix that. So we're going to rewrite that 6/5 as an improper fraction by saying topsy in the boxy. 5 goes into 6 one time exactly, with 1 left over, meaning that 6/5 is equal to 1 full time, with 1 left over. The denominator stays the same. So not only do we have the 6/5, which is 1 and 1/5, but we also have the 3. So now we would need to say that we have 3 plus that 1 and 1/5. These are our whole numbers, so we can add them together, giving us 4 and 1/5 for our final answer. And we'll do some more practicing with that, especially when we end up with a fractional part that is a little top heavy. So let's look at the next example. We have 2 and 3/4 plus 1 and 1/6. Again, let's stack them. 2 and 3/4 plus 1 and 1/6. We have our whole numbers lined up along with our fractional parts. This time we don't have common denominators, so we have to create them. If we were to list out multiples, we would say 4, 8, 12, 16, 20, 24. If we listed them for sixes, it'd be 6, 12, 18, 24. We noticed that we could use 24. 6 times 4 is 24, but 12 also shows up, so 12 is going to be a smaller denominator, which typically ends up being easier for us to use. So we're going to use 12 as our denominator. So just with the fractional part, we need to rewrite that. So 4 to get to 12, we would have to multiply by 3. So we're going to do that in the numerator as well. So 3/4 is going to become 9/12 because 3 times 3 is 9. And we need to bring that 2 over as well because we didn't just have a fractional part, it was a mixed number. The same process to the bottom. 6 times 2 gives us 12, so we need to multiply the 1 by 2 as well, giving us 2, and carry that 1 over to remember that we have a mixed number, keeping in mind that it is still addition. And now we're going to add those fractional parts first. 9 plus 2 gives us 11 out of the 12. 2 plus 1 gives us 3. This time we have a nice mixed number because our fractional part is not top heavy. Then we check to simplify. Just that alone, and 11/12 can't be simplified. So 3 and 11/12 is our answer. Let's do the same thing right here. We're going to stack them 1 and 5/6 plus, this time we don't have a whole number with a 7/8, so we're just going to put 7/8 underneath the fractional part. We could say that it was 0 and 7/8 to give us something to help line it up. We can fill that in with a 0, but we wouldn't need to. We do need to find a common denominator between them, however. We already have the 6's listed out, so we could say 8, 16, 24, and that one also has a 24. So rather than saying 6 multiplied by the 8 to get a common denominator, we can use 24 for our common denominator and write that in both places. 8 times 3 gives us 24, so we're going to multiply the numerator by 3, which is 21. 6 multiplied by 4 is 24, so we're going to multiply the numerator by 4, which is 20. And always remember to bring that whole number over, because it's not just the fractional parts. And in this case, it's going to be 0 that we bring over. And then we are going to add them together. 20 plus 21 gives us 41 out of the 24. 1 plus 0 is 0. So we have 0 plus this 41 24ths. However, this part of it is top heavy. So we need to simplify it by doing topsy in the boxy before we add it to that 0. Or excuse me, to that 1. That is a 1, because 1 plus 0 is 1. So when I do this, 24 only goes into 41 one time. So then we're going to subtract. Giving us 17 left over. It went in one complete time, 17 left over, and the denominator stays the same. So 41 24ths is the same thing as 1 and 17 24ths. That's super important to understand. We didn't change the value of it, we just rewrote that fractional part to be a nice mixed number, and we're going to combine that with the one whole unit that we already had. So 1 plus 1 is going to give us 2, plus our fractional part of 17 24ths. Then checking to make sure if we can simplify. 17 is a prime number and does not multiply perfectly to be 24, so this is in simplest form. A couple more examples similar to that. Again, we are always going to stack our fractions. 3 2/3 plus 1 5/8, the fractional part on top of each other, the whole numbers on top of each other. 3 times 8 gives us 24, so 24 can be our common denominator between the two. Maybe it's helpful to rewrite those whole numbers right away so that we remember to bring them over. To get from 8 to 24, we'd have to multiply by 3. So meaning we have to multiply the 5 by 3 as well. 5 times 3 gives us 15, so we fill in that mixed number. 3 multiplied by 8 gives us 24, so we have to match that in the numerator. 2 times 8 gives us 16, and now we've just rewritten equivalent fractions. It is addition, so we want to add them together, starting with the fractional parts. 16 plus 15 gives us 31. You can always show that off to the side. We don't have to do that in our head. The denominator stays the same. And then 3 plus 1 gives us 4. Again, we have to rewrite this fraction because it's improper. So we're going to rewrite it and then add it to the 4 as our whole number. So it's going to be 4 plus whatever we get for that improper fraction. So we say 31 divided by 24. It doesn't go into 3, but it goes into the 31 once, with 7 left over. 31 minus 24 is 7. You can always borrow to show that work. 11 minus 4 is 7. So when it went in one full time, 1 is our whole number. 7 left over, so 7 out of denominator stays the same. And then we just combine what we had. We rewrote 31/24 to be 1 and 7/24. These have the same value. And then we're going to combine those whole numbers. 4 plus 1 is 5 and 7/24. Again, checking to make sure that we can or cannot simplify. 7 does not go perfectly into 24. 7 is a prime number, so we can't simplify. Okay. A lot of times, the easiest way to find a common denominator is just by multiplying them together. However, sometimes that gives us a really large number, so we would want to find a different strategy by listing out those multiples to find the least common denominator. In this case, we're going to multiply them together. So 2 and 2/13 stacked on 1 1/2. Because if we were to count by 13, the next number, 13 plus 13 is 26, already an even number. And 13 times 2 is 26, the same thing. So that's why we would just multiply these two together. Carry those whole numbers over. 13 we would have to multiply by 2. So we're going to multiply the numerator by 2, giving us 4. The denominator, thus this bottom fraction, 1/2, would have to be multiplied by 13. So we multiply the numerator by 13. And then we can add them together, starting with the fractional parts, always first. 4 plus 13 gives us 17 out of 26. 2 plus 1 gives us 3. Checking to make sure that it's not improper, which it's not. It's a nice fraction. And we cannot simplify. 17 is prime, doesn't go perfectly into 26. So this would be our answer. A lot of times adding fractions together comes in handy when we're dealing with recipes. Doubling recipes or combining recipes to figure out what type of ingredients we need. So within this recipe, it calls for 1 1/2 cups of flour. So 1 1/2 is going to be our nice fraction. 3/4 cups of sugar. So 3/4 is going to be our nice fraction. And 1/2 cup of brown sugar. 1/2 is our fraction. And 5/6 cups of cocoa powder. How many cups of dry ingredients? So we want to make sure that all of these are dry ingredients, meaning they're powdery. Flour, sugar, brown sugar, cocoa, good dry ingredients. Does the recipe call for? So in this case, we are going to, how many in all, we are going to add them together to find the total amount of ingredients. So we're going to add 1 1/2 plus 3/4 plus 1/2 plus 5/6. So we have a 2 for our denominator, a 4, and a 6. We want to find a common denominator between all of them. So let's count by all of those numbers. 2, 4, 6, 8, 10, 12. We could even keep going if we wanted to. If we count by the other denominator 4, it's going to be 4, 8, 12, 16, 20. And then if we count by the third one of 6, it's going to be 6, 12, 18, 24. We want to find the least common denominator. In this case, looking through every single one of them has a denominator, or a multiple, excuse me, of 12, meaning we can have a common denominator of 12 for every single one of these. When we have multiple fractions, we can just write it straight out horizontally and then write underneath what that common denominator is going to be. So instead of 1 1/2, it's going to be 1. The whole number will always stay the same, just like it did up here in our examples. But now instead, we need to get a new denominator, which we said was going to be 12. To get from 2 to 12, we would have to multiply by 6. So we're going to show that as well. 1 times 6 gives us 6. So 1 1/2 is the same thing as 1 and 6/12. Plus, again, we need a denominator of 12. To get from 4 to 12, we have to multiply by 3. So that matches, giving us 9/12. Plus, again, denominator of 12. To get from 2 to 12, we have to multiply by 6, which gives us 6. And here we would have to multiply that 6 by 2, multiplying the numerator by 2 as well, giving us 10. Now that we have all common denominators, we're going to add all of those fractional parts. 6 plus 9 gives us 15, plus another 6 is going to give us 21, plus 10 is going to give us 31, so we know right there that our fractional part is 31 out of 12. But it wasn't just a fractional part, we also had that whole number, so it's going to be 1 and 31/12. However, this fraction right here is improper, so we have to simplify it. So we're going to take our whole numbers, our whole part, which was 1, and combine it with the fractional part, written as a nice mixed number in the end. So what we're going to do is divide 31, topsy and the boxy, by 12. 12 does not go into 3, but it goes into 31 2 times, because 2 times 12 is 24. 31, we're going to borrow from, giving us 11 minus 4, which is 7 left over. So it went in 2 full times with 7 left over, and the denominator stays the same. So now we have 1 plus 2 and 7/12. So we're going to add those whole numbers together, giving us 3 and 7/12, and then double check to simplify, which in this case we can't. This was a word problem, so we always want to look for a label. We want to know how many cups of dry ingredients, so it would be 3 and 7/12 cups of dry ingredients for our final label and answer. When we're adding or subtracting fractions and adding mixed numbers, we absolutely have to have a common denominator, and we always start by adding those fractional parts first.